Welcome to Nasdaq TradeTalks, where we meet with the top thought leaders and strategists in emerging technologies, digital assets, the regulatory landscape, and capital markets. I'm your host, Jill Malandrino, and joining us this afternoon, we have Eric Nakagawa, co-founder and CEO of Self Protocol, Jason Teutsch, founder of Truebit, and Rebecca Liao, co-founder and CEO of Saga. We're here to discuss the essential infrastructure needed for AI agents to become mainstream participants in blockchain ecosystems as the industry scrambles to implement these AI agents. There's three infrastructure challenges that have to be solved: human verification, execution, and governance. It is great to have all of you with us, and certainly a timely, critical topic. Eric, let's kick it off with you. What exactly is proof of humanity? Why has it suddenly become such a critical conversation within AI?
Thanks for having me, Jill. That's a good question. Proof of humanity is the idea that you can use cryptographic technology to verify that I or anybody on this call are real people. This information is very useful because up until now, it's been actually quite hard to verify this information. And the best part about this tech is that you're actually able to do it in a way that is that's private and secure, so that people can feel confident knowing that if they're proving that they're real people online, that they know that their information is not going to get leaked. There's no honeypot or anything to steal using some of the technology that we finally have access to. Yeah.
So, Rebecca, a word that also comes up a lot with your work is sovereignty as it relates to AI. What does that mean in practice, and why is it giving an AI its own dedicated blockchain so critical to function as it's designed to do?
Well, the whole purpose of AI agents on chain is to allow these agents to have independent economic activity. And so you don't need a human in the loop in order for these AI agents to engage with one another and to engage with people. And what that means is that these AI agents have their own independent spending power. They also have the ability to receive payments from, again, other agents or other human beings. And when we talk about sovereignty, that's what we mean. We actually don't really mean the sovereignty of people. We mean the sovereignty of AI agents as though they were people. And this is the whole purpose of having them verified on chain. Now, the reason why it's important for them to be on their own dedicated blockchain or set of blockchains is scale. So you think about just how big the language learning models are for OpenAI, Gemini, any of the major protocols out there for AI models. Now, if you want to move any of those on chain, if you're looking to verify AI agent models, then you need that kind of scale. In addition, AI agents can execute financial transactions at much higher speeds than human beings. And therefore, again, you need that scale. And when we architected our blockchain at Saga, it was designed for infinite horizontal scalability. You should have as much compute as you need in order for your AI agent or any application to perform properly. And that's why we have become a home for consumer agents on chain.
Well, Jason, let's talk about trust for a moment here, because once an AI agent is operating, it's performing incredibly complex tasks. So why do you think there's a trust gap with those computations, and how does Truebit's approach provide a verifiable proof of execution?
Sure. Well, the AI machines are intrinsically black box. Often an AI can't even tell you where how it derived the answer. And when you combine them together and you have agentic AI with processes talking back and forth, um, maybe AIs that are doing DeFi trades on chain, it's a big risk if you can't audit it and figure out um, who's responsible, or know that as a user you have control over the behavior of the AI, at least within the parameters that you want to give it. So it's it's audibility and risk mitigation kind of go hand in hand.
So, Eric, this sounds like to me it's just not executing simple commands, but the agents are actually acting with increasing autonomy. From your vantage point, how advanced is this trend? And what role does core infrastructure play in enabling an AI agent to operate?
Yeah, so I think the idea of AI agents acting kind of as if they're living or whatever and doing all sorts of different types of complex tasks, I think is very compelling and something that all of us are benefiting from. I do think that it's important to make sure that we're able to track all this information back to a person, hopefully, who created these things so that there's some accountability. Anybody who's online right now, if you're dealing with any sort of online social media or if you're participating in blockchain governance, it's really hard to tell who people are. And although I think it's great that there's new technology and new initiatives around giving AIs a safe place to play, I really want to make sure that the people that are, benefiting from or creating these have a way to prove who they are so that they can stand out. And in many cases, if things go wrong, there's a way to at least trace it back towards someone who kind of like created these things. In terms of other infrastructure, I think it goes beyond just the people that are creating these. I think it's also the technology that allows it to scale. And I'm not an expert on scaling massive amounts of AI blockchains, but I do think that any of the technology that we're using itself allows for both people and bots and agents to play together in a nice, cohesive way.
Yeah. And Rebecca, I'd like to get your thought on this as well in terms of with executing on more complex tasks and so forth. How does infrastructure play into this? Or even a more basic question, do we not even need apps anymore? Will everything just be done through an AI agent? Is the infrastructure ready for this?
The infrastructure is ready for this, but the interesting thing is it's not really the complexity that tests the infrastructure. So it's not the actions themselves, it is the thinking that goes into the actions. Let me explain that. So at Saga, a lot of the applications that build on us are more consumer in nature. So they are in the realms of gaming, entertainment, and social. And in order for an agent to be successful and effective in these contexts, it needs to have empathy. It needs to be able to hold a good conversation. It needs to not come across as a chatbot. And especially with the advent of character agents on Saga, where we are taking some of the most beloved characters, IPs, from gaming and entertainment and turning them into live agents, you need to embody that character as much as possible in the agent. And therefore, the thinking, the training model that goes into this agent has to be incredibly sophisticated. These agents not only need to be trained initially on a really great data set, they have to be able to learn, and they do learn very quickly. They adapt very quickly to their conversation partners. They are personalized for all the fans and the community members who want to interact with these agents. And so that kind of sophistication means that you need the training models to keep up with the demands of the consumer, but you can see that this can go into a very scary place. And so you need the training models to be trackable as well on chain. Not everything needs to be tracked on chain. An LLM that lives in a centralized database is always going to be faster than what's on chain, but the verifiability is what we need on a blockchain.
It's interesting, Rebecca, because then it leads you to the question of what are you judging the performance? Where's the competitive edge? Is it because it's a dynamic environment now, right? So how do you value that? Is it the reputation of the agent itself?
Partially the reputation of the agent, but the agent always serves a purpose. And therefore, the agent can provide customer support, for instance. That's a very basic use case. Or it can actually sell things to a particular fan or a user or a community member. So for instance, let's look at a game. Say you're talking to this agent, it's a beloved character in the game, and the agent can tell from your conversation that you are struggling on a certain level of the game. It can then just drop you game codes, which are entirely valuable within any sort of gaming ecosystem. It can drop you battle passes. It can drop you merch from that particular title. And that just really increases your loyalty and your willingness to spend in that particular game. So that's really the kind of interaction that we're looking at.
Jason, let's talk about transparency and the audibility of transcripts of AI's actions. It's going to be critical, especially when you're in high stakes environments and it is making these types of financial and consumer decisions for you.
Sure. And the level of complexity goes up as the number of AI agents involved goes up. I mean, it might not just be one or two agents. And so these processes, I mean, having a toolbox, you have to, the whole process will be orchestrated. Maybe even an AI is creating that orchestration, and now you have to go out and verify it. So, well, I mean, what you need is a tool that can take the whole orchestration end to end and create a proof of it, including API calls, including code executions, and any other steps that are in between. And so that is that's sort of like, I guess, the level of complexity. It goes beyond really what you can do just on a blockchain. So the transcript itself is sort of what we do is we take those series of processes, whatever they are, API calls, code execution, API call, and wrap them together in a proof that so you can show to a third party or maybe even another agent that this process, these 3 steps or 4 steps, 5 steps, whatever it is, took place with this particular result at this particular time. And so you can have more traceability, and that can include the training of the model. It can include the inference of the model. It can include the communications between the different agents so that you maintain some control and visibility into what's going on in a complex system. So that's what the transcripts do, and maybe the AIs are even processing those transcripts, and it's to change their behavior over time. I mean, there's just yeah. I mean, you cannot let the machines.
Right. I mean, at the end of the day, is what if the machines make a mistake, right? And we'll get to that in just a moment. But Eric, before we get there, I want to talk about building this new infrastructure. It has to be based on trust, right? So from your perspective, what's the single most important principle for establishing that trust between humans and the autonomous systems that they use?
Yeah, so to establish a trust, I think what I was hearing Jason say was kind of combining and creating these sorts of proofs that allow you to verify information. For self, we actually use that as well. So we do 2 types of cryptography. One of them is verifying that identity documents like biometric ID cards or passports are valid and actually come from the country of issuance that they say they are. This helps with impersonations and things like that, so people can know that we can release a proof on the user's behalf that verifies that they're a real person. And then beyond that, they can reveal parts of their data in a way that I think would work really well with AI, where they may not want to share all their details. They're able to actually just share a bit of it, like maybe that I'm over the age of 18. I can play some games that I couldn't if I'm not over the age of 18, or if I can share the country that I'm a part of. And in financial areas, especially when you're dealing with DeFi and all the bots and agents that are going to be doing trading and trading on my behalf, making sure that I can verify that I'm the person that set this agent or this group of agents in motion, I think is going to be really important. So that for example, if I have a trading bot using one of the infrastructures on from the interviewers here today,
Right.
it came from me, and I can go back and I can change it, I can stop it, I can modify it, but I know that I'm the one that controls it. I'm the one that created these things, and those together, plus these proofs, which are a little bit more complex than a casual conversation here, but those proofs allow us to mathematically verify that this information is true. If it's my information on my identity documents, if it's an agent did this or got data from here, all those proofs are finally available through technology that's been around for decades, but finally it's something that can almost be done in the palm of your hand. And we're getting very close to that. And I think it's going to unlock a lot of things for all of us, humans and agents.
Yeah. And Rebecca, I want to ask you this question in a different way. How much control do humans or users actually have? We hear so much that it's all about user experience and for customers to get from A to B, and it's seamless and it's familiar to what they're used to. And, we shouldn't have to worry about the back end. But what if an agent makes a mistake? What if there's data that's being disseminated that you don't necessarily want out there? Does the human, are they still in the loop as it relates to using agents?
Sure. So results are always in the loop. And part of the reason why it's important for these AI agents to have their actions and perhaps also their training models tracked on chain is that you can verify what those actions are and you can verify the data that went into feeding those actions. And if there is a mistake, if there is hallucination from the AI agent, then you can fix it next time around. Now, the real battle is what happens while the agent is still learning. And this is something where the models are actually getting quite sophisticated because they are modularizing. So it was the case that these large language learning models are really about taking monolithic sets of data and then processing them into the best possible AI-driven outcomes. But now these agents are becoming training models in and of themselves. And so the agents are working together in order to produce the best answer or the best outcome based on the user's query for an AI product. So these AI agents, super swarms, are coordinating, they're working together, they're learning from each other in a way that mimics human social behavior to make sure that we come to the best collective answer. So the short answer to your question is that the training models are changing. It allows for a lot more flexibility and customization. Our experience with this is that the brands that want to implement these AI agents definitely think about control. They are much more open now. They are not trying to control these agents with the same kind of stringency that they've been trying to protect their brands with previously. Having said that, Mickey Mouse cannot curse, for instance. And there are certain aspects of these characters that they have to control as a brand, and they can do that now with these learning models.
Jason, does this run into the risk that we've seen with Web 2.0 where algorithms, create these echo chambers, if you will? What if you are operating with an agent and you want more control and you don't want what it thinks you may want, like we see in 2.0 now? Is it designed not to do that, or are we still going to run that risk where you're being fed things that you don't necessarily want to be fed?
I think you can set guardrails on these machines, but of course things happen so fast that you can't always correct them in real time, but you should be able to audit and react to it. I mean, there are ways to, I mean, maybe you can get Mickey Mouse to curse. I mean, it's, there's always, AIs, maybe you can train an AI to try to do something like that. And there, so that's certainly possibility. I mean, I like what what Eric said about proofs though, and starting with these identities. Every time you have a proof, you're going to start with some set of axioms or theorems. I think this is sort of the the you have to start with some kernel of truth or basis. I mean, whether it's these parameters around what Mickey Mouse can talk about, or whether it's, hey, I trust this cryptographic technology to be able to read passport data and input that as a source, or maybe it's, hey, I trust smart contracts, something like this. And the whole idea here with verification is that you can, just like we did with the verification game, which is used in optimistic rollups, which is sort of the basis for Truebit, you can proof them up. Like smart contracts, like being is sort of a kernel of truth. The goal of these applications or the verification game is to take them and spread that credibility across broader applications that are useful. So that, and as you said, when you get into this, as Rebecca was talking with generative AIs, and they of course AIs will learn from each other, and so that always makes it a little more interesting, I guess. So I think we're just at the beginning of the complexity here in this space for AI infrastructure, but
Yeah,
we'll see.
it's going to be interesting to see how it plays out because I think, and Eric, to wrap up with you here, the consumer, the end user, I feel as if we have a little bit better understanding in today's day and age of how our data is being used and some of the good and the bad that comes out of algorithms thinking for you and what it thinks you want to see, right? So I'm hoping at least with the agents, we won't run into the same problem again because it really hasn't solved anything otherwise. What are your thoughts as you look forward?
Yeah, so as we look forward to this, I think having traceability and verifiable people allows for agents to really unlock a lot of their creativity or the creativity of these creators. I think that by having someone verify who they are, if they're doing like a digital twin, or if I'm creating sort of a facsimile or a version of myself, I want to make sure that I can always go back and take it down if I don't want it up there anymore. I think as things start to go second level, where they're my agents are creating agents, I think having that traceability is going to be really important. And again, doing this all on blockchain, yes, there's a lot of data. We have a lot of new technology now using things like zero knowledge proofs to help verify this information, both about individuals and making sure humans are still in the loop somehow, and then also any of the data that is being brought on to help these AIs train. But connecting it all back to people, I think, is really important. At the end of the day, if I'm creating a trading bot to do some sort of fun stuff on DeFi, I want to make sure that if that thing starts running out and not making me money, I can go in and turn it off. But ultimately, technology will keep advancing. Proofs generation will become faster, and we're going to have more people coming online and more people looking for different types of way to take advantage of, hey, I'm a real person, give me something that I can do that's fun and exciting with all these great agents and new technology.
All right. Appreciate all of your insights. Thanks for joining us on Trade Talks. I'm Jill Malandrino, Global Markets Reporter at Nasdaq.